Okay, welcome all. If you're still getting settled in, I'll have a few intro slides to go over. A reminder that we have food on the far right over here. And if you're just joining us, try to sit in groups of 4. We're going to have a group discussion activity later on. And Zoom participants, you will also be able to join this group discussion. Okay, so for this first half of the event, we're going to do a discussion activity. And so this is a community of practice. It's not a seminar. And so in any community of practice, members are the key resource. And so in groups of 4, we're going to discuss the prompts that are shown on the next slide. And so please leave space for each person in your group to share ideas for about 1 minute. We'll have 5 minutes per question. And be respectful of different backgrounds and experience levels. I know some of you are ML experts. Some of you are coming from completely different fields, biology, whatever it is. And so some people are just getting started in ML, and just keep that in mind. And again, we're going to remove the discussion component from the recording unless everyone opts in to have it shared. And finally, I would like at least one person, possibly 2, to record your responses in this Google Doc that I've created. So go ahead and navigate to that link. Okay, so here are your prompts. And these prompts are included in the link. Let me toss this link in Zoom chat. And let me also pull up a timer. So before I start this, go ahead and take just a few moments to read over these prompts. For the first 5 minutes, you're going to want to briefly introduce yourself. Try not to spend too long on the intros. I know the intros are always some of the best parts of these events. You get to meet other people, but try to keep it relatively brief. And then discuss, why do you believe it is or isn't important to share machine learning models? How has model sharing contributed to your projects, if applicable? So go ahead and start discussing with your groups of 4, and I will open the breakout rooms. Okay, welcome back all. And so we have this doc to keep track of what everyone has written here. It's looking pretty comprehensive. Let's see, enabling people without compute resources to train their own models. It's plus 99,000, so that one's definitely, keep that one there. Models can be dangerous in the wrong hands. That's definitely a response to the next question. So I'm glad you pointed that out, though. We'll talk more about that in just a bit. Allowing others to reproduce your results. Yeah, is it really even science if we can't reproduce it? Invite collaborators to accelerate and improve the project, add on to existing work. Multiple eyes can ensure quality. Not everyone has compute resources, but everyone should be able to use the state-of-the-art model. Yeah, so democratizing AI. Let's see. I'm not sure I see fine-tuning on here. So, models can be repurposed for different tasks. That's what these foundation models allow for. Or pre-trained models can be used for similar tasks that they were trained on. And so that's probably the number one reason for me anyways. And yeah, feel free to add additional thoughts to this document. Is there anything I haven't commented on that anyone would really like to mention?
If you use publicly available data, you should share the model with the public. This point is interesting.
Yeah, so if you use publicly available data, you should share the model with the public. That is interesting. I mean, I think you can think of arguments for and against that, but it's certainly something I think our researchers and people that are passionate about open source material should strive for. Okay, let's go ahead and move on to prompt number 2. And so you can find this in the document if you just scroll down. I will go ahead and open up the breakout rooms. And again, you'll have 5 minutes here. And so let's go ahead and look at what everyone has written here. Looks like we have a lot of good points that were brought up. Restricts commercial potential for authors, owners. Yeah, that is the trade-off when you're making things open source, unfortunately. Getting scooped before you publish, that can be a real risk for researchers. Although, once you share that model, hopefully it would inspire lots of other future directions of work. Risk of violating U.S. export controls. That I'm not sure what that one's referring to. Whoever wrote that, do you want to comment on it?
Yeah, that just came up in an unrelated meeting I was in today with cybersecurity about a concern they're looking at with general use, actually coincidentally, use of AI chatbots, where it's potentially the university is under federal regulations to not share, well, I guess everybody is, certain technologies with certain countries.
Gotcha. Yeah, that's an interesting one to bring up in the legal context. Yeah. Privacy concerns, that is probably one of the most important things we have to watch out for. Um, Once you're sharing a model, you are also sharing remnants of the data it was trained on. And so if you're training on private data or sensitive data, that information can be recovered from the model if people try hard enough. And so it's really important that we don't share models that were trained on sensitive data. Potential bias built into foundation models. Yeah, does anyone have an example they want to share here? Anyone hear the story about face detection and how people can use those models to try to look for criminals, and when they're trained on data sets that contain predominantly white people, they make more mistakes for people that are darker skinned, and so you end up harassing people that are darker skinned from those face detection models. So there's been real cases of that happening. It's something to watch out for. Let's see, hallucinations, interpretability is important. Propagating errors and biases, bias from training data, lack of learning. What about challenges? I don't see too many challenges here. Yeah, exactly.
Something that I mentioned was that, like, per se, in like a healthcare setting, if you're trying to give a collaborator in a different hospital your model, they're going to be like, okay, well, how do I train this? I can train on my own data, but then that whole concept of generalizability between hospitals is a little bit difficult, right? So that seems to be like, it's great to share these models with other people in other hospitals, other states, whatever, but it's super difficult for them to see the same thing that you're.
That's a really great point. Yeah. So understanding the model's scope and its generalizability, it's not always easy to say for sure if a model is going to work in a different data set, a different context, where that data might have a slightly different shape to its distribution. And people are expecting them to generalize well. Well, that's not always the case. Also, just controlling your coding environment. If you hand someone your model weights, that's not really sufficient for them to reproduce your results exactly. You have to also control for the libraries you have installed, what operating system you're using, what GPUs you're using, all those rounding errors. And so it can become really difficult to 100% replicate training a model unless you use some really key strategies to do that. And we'll get more into that later today. Okay, great discussion. Feel free to add to this document later. I do have one more, although 1225. I think what we'll do here is just have an open discussion. So what pieces must be well documented to ensure responsible and reproducible model sharing? What do you guys think? Let's get a few ideas. Is that a hand?
Yeah.
Yep.
And like the same way, like you look at a recipe to like bake a cake, you need the same like have a recipe to train a model. So it includes like the ingredients, which in this case would be like the data, and then like other things like training code, stuff like that.
Yep, the data is one important piece, and not just the data, but who collected the data, what are the data rights, is there any bias in the data, what does the class balance look like in that data set, how did you do the data split, what libraries do you have installed? Let's see, and I also have a whole list of these, which I can just copy back into this document. Model architecture, model weights, pre-processing steps, all the pre-processing steps you used, clear instructions for environment setup, evaluation metrics, ethical considerations. This is a really big one. You don't want to overlook this. If your model involves human data in any way, shape, or form, or if it impacts decision-making downstream that could affect humans, you really need to think carefully about this and how your model might be used in the future. Okay.
I have a point real quick.
Yeah, sure.
Yeah, I think another important piece is just when you're sharing the model to share your experience with it, like as the person who developed it, and include best practices for how to use the model. Because a lot of these models, there's lots of different ways to use them. And like, if you're going to go fine tune something, there's a lot of these decisions of where to put the prediction head or whatever you're doing. So yeah, I think part of releasing a model is providing that text.
Yeah, kind of talking about subtle variations of the model and the intended use cases of the model and the scope. Yeah.
I just want to add one more point.
Sure.
I know Like for example, OpenAI, when they release their model, they also do some internal testing, like hire a bunch of people to do red team testing. It would be good to share some testing example that to show people that at least how confident we could test this model in certain cases.
Yeah, it's trying to give sort of a short demo of
Yeah.
different use cases and how it reacts to different kinds of data. Yeah, the more thorough you can be, the better. And that's going to help out future researchers if that is your audience who will be using your models.
Yeah, because I also want to add one comment. Like,
Sure.
it is similar to like doing an open source GitHub project where people just post an issue, so anyone else can come up to fix it. But if we want to share a model, we also want to actually identify potential issue of this model, and maybe we will come up with better ideas to train this model, or come up with better training data to contribute to the repository and train a better model in the next run.
Yeah, exactly. So kind of the more documented you can be when you do share your model, the more likely people are to build upon it and actually use it. Yeah. Great. Okay. Thank you all for your contributions here. Feel free to bookmark this Go link or save it for your records. I can also send a copy out via email. And let's jump back here. So I have just one last slide before I'll hand it off to Haotian for today. I have just recently started drafting a guide on how to share a model via Hugging Face. And so for those of you that aren't aware, Hugging Face has become kind of the gold standard or go-to option for sharing models with others. And so please take a look at this draft and add your questions to the bottom of the document. We're going to invite other people in the ML+X leadership team who are working on a resource sharing hub. We're going to publish this in the next few weeks. We're calling it Nexus. That's the working title. Sounds really fancy, right? And so Nexus will be publicly available for others to contribute to in the coming weeks. And so if you have any questions on how to share a model via Hugging Face, please visit that document and add your questions to the bottom. We will make sure to respond to those questions when we produce this guide. Okay, so without further ado, I do want to introduce our second speaker today. So Haotian Liu will be talking about LLaVA-NeXT and model sharing. And so Haotian is a CS PhD student who's graduating this year, correct? Yep. And he recently released this model. It's become very popular. It's a foundational model that does multimodal learning. So it uses vision and text data. And it recently beat Gemini Pro, that's Google DeepMind's model, on several benchmarks. So let's all give him a warm welcome.
Hi, everyone. I'm Haotian, and it's a great pleasure to be here and to tell about LLaVA and also model sharing. And it's great to have a super diverse community, and there are definitely questions and challenges for you to help us as well. So like LLaVA is a multimodal model, and the reason why we want to build such model is that we as humans, we can see and reason about the visual world and express and interact with others with natural language. Just like doctors read the CT scans and directly explain their findings to their patients, teachers will teach students with conversations, and we will share our life and finding on social media and interact with others using natural language. And it will be great if we have a visual intelligent assistant that can interact with people using natural language, and people can control their behavior using natural language instead of like training like traditional machine learning models where you need to define your task, like train your like feature extractor, like train different regression models. You can just explain like what you want your model to do, and it has a general interface. And it will be great if we can have a vision language model that can accept both images, text, and also for multimodal, hopefully we can have audios, videos, and more modalities so that it can see what we see in our daily lives, and it just interact with us as human does. And GPT-4 vision was demonstrated by OpenAI last year, and it has strong visual reasoning capabilities. And by visual reasoning, or how GPT-4 vision does, is that given such image and a user instruction like what's unusual about the image, the model will be able to identify the relevant context, perform complex reasoning, and identify that the unusual thing is that the man is actually ironing the clothes when he is standing on the back of a taxi. And so it's great is that we now have such models that have great capabilities, but it was not accessible until late last year, and there's no disclosure how it works, and it's also closed source, so that we cannot easily adapt them to different needs, and we do not actually have access to its like deep model behaviors. So like we want to build our like open source counterpart, which is LLaVA. It's an instruction following multimodal model. By multimodal, we mean here is like vision language, where the model can accept the text, which is instruction. It can accept the image, which is like another modality. And for instruction following, we mean that the LLaVA model will be able to understand users' instructions. It will be able to reason about the image based on the user's instructions and output the response in the text format. And basically, LLaVA has image and text in and text out. And we also want to see like how we can build such model, like take a slightly deeper dive. So basically what we do is that we will feed the image into a vision encoder, which can extract the features of the images. And there's a cross-modal connector that can bridge the connection between a vision encoder and the language decoder. So the language decoder will take in both the vision feature and as well as the instruction, which is a language feature. It can perform the reasoning inside, and then after it's finished the reasoning, it will output the response in the text format. So basically, this is like how our model works. And we also need training data to train such models. And the way we train such, and we in our paper, we try to find a way to collect and generate such multimodal instruction following data. And basically, like multimodal instruction following data or visual instruction following data here, we mean that we want a triplet of the image, which is the input, instruction, which is another input, and the answer, which is the ground truth output. And we want to train the model on this triplet to be able to follow the instructions. And so like what we did is to use OpenAI's text-only GPT to generate such instructions. And the reason we did that is that at the time we trained LLaVA, there's no like open source or like teacher model like GPT-4V that's accessible publicly. And also like even GPT-4V today can make some mistakes that seem stupid to people. And COCO dataset is a commonly used vision language dataset in computer vision that have those annotations of those images. Basically, it have like image level context, which are captions describing what's happening in the image. And it also have like the region level context, which are more fine-grained detail on what the image looks like. And those are annotated by human. Basically, they are much more accurate than a model's prediction. And also like with those information, a text model can guess what's happening in the image, and it can have a sense. With those information, it can somehow behave like a multimodal teacher, but with some ground truth information. And then we build our text-only data engine to generate our instructions and answers, which is basically in-context learning capability of GPT models, where it can mimic your examples and try to figure out what you want. So regarding in-context examples, we're going to feed the image context into convert them into the text format that we just described. We write some instructions and answers where the instructions are about the image, and the answer are the target answers, like the unusual thing is the man signing clothes in the minivan or something. And then we can sample as many images from our COCO training dataset as we want. We convert them into the text from user instruction, from the user's annotations. And then GPT can learn from like what you want, and also like learn from the input data, and it can generate the instruction and answers for all the new images. And in this way, we're able to generate the visual instruction following data, the triplet of image, instruction, and answers, and we can use that to train our model. And regarding,
Sorry,
sure.
quick question. Do you verify, like, are humans verifying this new data, like this new training data, or do you just like use it like in?
Yeah, that's a good question. Like, it's important to ensure that your data has high quality so that your model do not make stupid mistakes. And we find that we manually evaluate like around 100, and also we use a GPT-based pipeline to do some evaluation. Like most of the data are correct because our ground truth texts are correct, and also like GPT has a good understanding of those object coordinates. However, there are chances of hallucination and also like some incorrect interpretation of the image context. And we find that there is a small proportion of the data that's kind of that way, and we are able to filter a part of them out using rule-based methods. But there are still some like errors or like noises in our release data. But we find that the model is quite robust towards those noises, as long as they are just a small part of it. And also, like, there are recent works that are based on reinforcement learning and also supervised fine-tuning to further reduce those errors that are coming from these. And also, like, we believe that there's a like future plan of building a data spin wheel to like further increase our like data quality.
Thank you.
Yeah, thank you for the question.
Sure. One question. So this data generation pipeline is based on solely the text, like the image caption and some information, but like image caption can be can just represent only a small portion of the image content. Is it possible that it will miss certain important content, or it will generate something that is contradictory to the image content?
Yeah, that's a good point. So yeah, it can definitely happen, and there are some follow-up works try to address this problem. By first is to like recall that we have bounding boxes where are like object categories and like bounding boxes, and like a follow-up work further expand this description of the object to be much more detailed, so that like the model can now have a better sense of what's happening in the image. And also like we also find that if you plug our pipeline into GPT for vision, where it has some like already have some visual reasoning capability, but may not be necessarily correct, with those of the annotations, it can be more confident about those information that are presented in the image, and basically the accuracy can be further improved in this like as you add more supervisions. And this is also part of our plan to make like create our data spin wheel, where like a similar idea is presented in another paper from Meta, like segment anything, where you first give some raw annotations, train a model, and this model is like not super good, but it can generate some good like proposals. And then instead of letting human annotators to annotate all the data from scratch, you can start from those proposals, so that maybe previously, like for 1 minute, like a human annotator can only annotate 10 images. With those proposals, they can now annotate 100 images, so that you can increase your data by 10 times with the same amount of budget. And then you can train an even better model on more data, and you can have a better proposal model, so that now the human does not need to make so much corrections, and maybe in 1 minute you can make an annotation of maybe, for example, 100 images, and then like you can create a data spin wheel to get more and more data. And similarly, in our case, we can also like create some data spin wheel in a similar fashion. Yeah, so regarding our model architecture, we use like we use a lot of open source models. For our vision encoder, we use Clip from OpenAI. And for language model, we use instruction-tuned language models like Vicuna, Llama2Chat, or MPT-Chat. Like LLaVA is basically quite robust to many kinds of those open source models. And we train the model on the generated visual instruction following data, so that the language model can understand the image and also follow multimodal instructions. And after training, LLaVA has several interesting capabilities that we find, and we hope that this can allow you to like see like what this can somehow potentially help with your own use cases. First is that LLaVA has like nice visual reasoning capability, as GPT for vision does, that's recognizing the unusualness of the image, and great OCR capability to recognize, like, for example, NeurIPS 2023 from this slide, and also correlate this NeurIPS 2023 with its pre-trained language knowledge, that NeurIPS is related to machine learning and artificial intelligence. Also multilingual capability, so that although our models are pre-trained with like mostly visual instructions in English, it can give proper response to Chinese instructions as well. So like it can allow people are also using it for different languages, and also like fine tune it for different like countries and region. it can also give you controlled outputs in some certain format, for example, JSON format. And this can allow you to generate data or do some data extraction in a controlled setting so that you can post-process it easily, use some like external tools like Python or like other data processing languages. You can also like, this is another interesting example that we find from our user, that you can just instruct it to do something that you want by natural language. Like Stable Diffusion is an image generation model where you can give it a sentence describing the image content, which are called prompt. And and when you're generating a prompt for a Stable Diffusion model, usually there's some like good ways of writing such prompts so that the model can generate like the best quality images. And user usually wants to like generate the prompts automatically from a lot of like images. And this is one of the examples that you can just control the model's outputs by just describing it. Like here's a formula, like just give something like a cartoon style image of some adjective, subject, haircut, clothing, doing some action and color scheme, and also some of the like the descriptions, and the model can generate exactly the same thing as you instructed by some natural instructions. And yeah, these are some of the examples of what LLaVA can do. And also, we recently released LLaVA 1.6, where it significantly outperforms our previous version, LLaVA 1.5 13b, based on some additional scaling in terms of model data, as well as some training like hacks. And it matches Gemini Pro on selected benchmarks. So yeah, now let's talk about open source and model sharing, where we really want our inputs. And first is that like LLaVA actually benefits a lot from the open source community, where our language model comes from many open source language models like Vicuna, Llama, Mistral, and Clip comes from Clip. And our code base, the efficient loading of those models are implemented by Hugging Face transformers. And also, like we have a great collaboration with Berkeley's LM-Sys lab, where they have Vicuna, which we use as a base language model. They have recently introduced SGLang, which allows you to efficiently serve language models with high throughput and efficiency on a single GPU or multiple GPUs. And also they have their fast chat, which is a base of our training code. We modified it for training multimodal models. And yeah. And LLaVA also contributes back to the open source community, where we open source all of our models on Hugging Face, where we find it to be super fast to download and upload, and it's free. And it has great integration with transformers. We open source our code on GitHub, open source our data on Hugging Face as well. And it's one of the best form we find to allow you to upload large file for free. And after we release LLaVA, actually like community, open source community actually benefits back to LLaVA in a lot of ways that beyond our imagination. That open source community helped us integrate LLaVA to transformers, which allow you to like run LLaVA easily with like several lines of code. Llama.cpp that allows you to run LLaVA on Intel CPUs. Text generation UI that allows you to have a great interface of different language models and multimodal models. SGLang for efficient serving. And after we release code, like many useful community PRs, pull requests help us to integrate for different hardwares, environments, efficient serving, different language backbones, vision backbones, and also like improve the user interface. And for data, like there are lots of follow-up research works to improve our data in terms of quality, capacity, safety, different modality, different downstream tasks, super useful. And we also have an online demo that we serve on our lab servers. And we do find that there are some pros and cons. So it can definitely help you promote your work where you have a demo that people can play around with it. And people can provide you with interesting use cases and test samples. For example, the Stable Diffusion example that is coming from our users, and we did not imagine that to work actually. And also, like there are some disadvantage, like to serve your demo, like you will need to like make it run 24 hours a day, and it has some cost. You will either need to occupy some of the GPUs in your lab, or you need to like pay for it. And also, like when your model is not doing well, like if it gives you some bad results or your demo crashes, this may like give people bad impressions of your work. And regarding the cost of serving, actually, we find that like there are several ways of from the community that we can benefit from. First, Hugging Face space. It has the Hugging Face community grants, which allows you to run your demo freely with some like basic GPUs like T4 or A10G with 24 gigs of VRAM. So it's sufficient for run some large models already, like with quantization, and also CollabNet notebooks. And those are actually also like contributions from our community. They help us implement all of these. And regarding model cards, basically we include a brief description, model date, papers, license, intended use case, training and validation data and metric to describe like what we how we train our model and what we're how the user should expect from our models. And there are some challenges. Like first is reproducibility. And first is that as LLaVA becomes popular, we really find that different people have different hardware, software, and different levels of expertise. And some of the instructions may not be clear enough, and it can confuse people. So you really need to like make sure that your instructions are understandable from people that's maybe out of your expertise, so that it can be used by covered by a wide range of audience. And also, like you will never know like how people are going to use your software. So like basically you have to learn from your users, from your pull requests, to make your like instructions much more clearer, and also make sure that the code is robust. And also, it's a great practice to provide example scripts so that people can directly start with, and also clear instructions so that they can start step by step. And also, like people tend to ignore your instructions, even if you make it super large, like you bold it super large, people will just ignore it. And if there's something super important, just try to break it into several parts so that you force people not to like just copy paste everything. And also like keep improving based on the user's feedback. And we find it super useful, and it can allow your code base, your model to keep improving over time. And also like privacy. Like actually, like in LLaVA 1.6, we find one important improvements from LLaVA 1.6 is that we gathered users' data to understand like what the need is from the user, and we train, we generate, we pseudo label those data using GPT-4 Vision, and then we fine-tune our models to make the models work more better on the use cases that our real world users are cared about. And we also want to open source our data, but like as we can imagine that although they are super valuable, but it can raise privacy concerns when we release. And also, like for example, like if a user accidentally uploads their driver's license or something that can potentially contain their private information, like to our demo, we need to probably remove it in when we release it. But sometimes those data can actually be super valuable because these are the form of the data that we should be expecting. And with images, it can be hard, or at least much harder than text, to like do some anonymization or these kind of things. So yeah, like any ideas on like different solutions other than anonymization or something? Like how can we ensure that we can provide the user with best data possible, but also like do not necessarily have like privacy concerns? Sure.
Not a solution, it's another problem. But do you worry about the private data somehow being recovered from the model itself at any point?
Yeah, I think like already there are some works that can recover your training data from your like models. Like And also, I think there's a recent paper from Google, like they can just query ChatGPT for like maybe 3,000 times, and they can figure out what your model architecture is. And it's somehow like definitely a concern. And but I think like for these kind of problems, like we do believe that there will be further ways to like improve it, like anonymization or like further distillation to avoid those to protect the model from those attacks. Sure.
Yeah, so I've been talking to some people in industry. They also care more about the data, and clearly this production level model would not release their data. But for open source user or community, what I'm thinking like here is that whether we can have some repository to collect those data,
Yep.
crowdsourcing, and then people can just send a pull request to say, oh, I can submit some of the data I generated, and someone maybe just doing a proof reading or review to just make sure that they can like commit this to the central data repository.
Yeah, good point.
Yeah, and I heard from someone, they say that if the model accidentally was trained on some very toxic data, even one piece of the information would destroy the model. So it'd be good to actually like open source all the data that
Yeah.
we can basically guarantee that this model would not actually have some corner cases that would do some like weird behavior.
Yeah, exactly. Yeah, so yeah, we can filter data before we release them. We can try to obtain the user's consent, but as we know that people do not necessarily read the terms, so and also like allow takedown requests, but they somehow can potentially exist in the Git history if we release it in like GitHub or Hugging Face. And also like another challenge, interesting challenge we find is like about the license, like people want to use and have been using LLaVA for commercial purposes. They are using them to build startups. They are using them in the business to like label the user data to train their own model, and they want our model to be commercially viable. But we're not lawyers, so like to play the safe, we previously released it with some non-commercial license, and latest we just released it with the original model license like Apache or maybe Llama 2 license, which is kind of commercially usable. And when people explicitly ask us like, hey Haotian, like your data seems to be not commercially usable, why do you release it on what can we use it commercially, like the models? And I have to like respond to them indirectly saying that, like repeating like a ChatGPT v2, like our model is released under Apache 2.0 license, period. And basically not like, yeah. So like any ideas? Like I guess like if we have a like broader range of audience, any ideas on how can we potentially like deal with it, or if there are any resources in our university? Oh, sure.
I wonder if you talked to Worf about it.
Yeah, we briefly talk about it with Worf, and they but like what we heard from them is mostly like do not open source it, like ask for like commercial like license if they want. And yeah, somehow like it is helpful, and like basically like Llama 2 license is somehow like a version of that where you allow people to use it freely if you're just for use it for research purposes, where your business is not significant enough to pass a certain amount of like users. But I also heard from some friends from some big tech companies where the lawyers are super concerned about those licenses, because like if there's a research lab in a big tech, big company for like Google, Microsoft, and the lawyers are actually concerned whether you use it for research purposes using those models, whether you're allowed to use it or not, because like it's kind of like confusing the way like Meta writes their license. So yeah, it's kind of like a dilemma for us. Like, sure.
So what do you want as the researcher and developer? Do you want to make money off this, or do you want it to be open?
Yeah, I think at least for me at this current stage, I want it to be like as widely used as possible, and it actually benefits me the most. I do not expect I become a billionaire by like asking the company to pay like millions for using my models, but it can make people the companies pay millions of dollars to hire me to work full time. Yeah. So yeah, then like yeah. So like basically what I want is to make at this point to make it like as commercial as widely used as possible, but not necessarily putting me into legal trouble. Although I do not think companies are going to sue me as a PhD student.
There's always the legal risk of making it completely open and unrestricted.
Oh yeah, so
where the risk is coming
yeah, so one potential risk is that when you're using like OpenAI GPT to generate your data, like it actually has a term saying like you should not use the
I see.
GPT's output to train models that compete with OpenAI.
Because you use the
Yeah, so yeah, if people if I'm making money to from that, I'm not sure if I'm competing with OpenAI or not, but like we're competing with OpenAI in a research fashion. Yeah, please.
The university is now paying Microsoft for us to have access to Copilot.
Uh-huh.
And actually, I just discovered that, and so we have all of that. So the university is spending a lot of money on that. What impact would it be on research like yours? Because we already have it. And so I don't know what question I have, but I want to make people aware that we have Copilot.
Uh-huh.
And why would they spend money trying to make your model run on the GPU that they have to pay money for while they can just ask Copilot?
Yeah, that's a good question. Like, whether you want a closed source model or an open source model. I think regarding like for some of the like I think like not only like Microsoft provides those closed source models, OpenAI also provide those closed source models. And what we see is that most of the big companies will choose Microsoft as their collaborator to like purchase those like API access instead of choosing OpenAI because they do not trust OpenAI. So I think it's a matter of degree of trust you can give.
I have one more question because you're a PhD student.
Yeah.
You're right. You're working on this, and I've seen so many student projects being great, and then as soon as they graduate, then the project kind of doesn't grow anymore, doesn't go anywhere. Do you have plans once you graduate to keep working on this, or passing the relay to some other people? Because that would be a good way for the project to be
exactly
fruitful,
yeah,
to something maybe that's even different than Copilot and then provide other services.
Yeah, exactly. Like for LLaVA V1 and V1.5, we are working as a small team where I write 100% of the code and train all the models, like babysit all of the models I have trained. And starting from 1.6, we're growing our team as a LLaVA team. And we're having collaborators from Microsoft, from ByteDance, from National University of Singapore. And also we have collaborators at Berkeley, and we're also like receiving lots of requests from the community that wish to join our effort. And yeah, we're going to build our like whole project as a team.
Super.
Yeah, Copilot, Microsoft Copilot is actually like in basically like the university. I don't know what is the pay in this case, but it's just like university. They opened it up for the whole student within. One thing is like, they are really assuring us, like when you put the data into the Copilot, it will not go anywhere. I mean, that's like really one assurance from Microsoft. And I think it's great, like, you're working on this project. It's excellent, like, for us. Hopefully it will be like, the product for the other people to use it.
Yeah, thank you. And actually, like, I think one interesting concern I would also want to bring is that, like, there's a very interesting, like, there's a startup called Inflection, like, and there is a like piece of news like saying that if like inflection is post on X that saying like inflection is just a wrapper of Claude 3, where like the model response of the same question is actually the same as the one that you can obtain from Claude. And someone is posting that on X, and the people from Inflection are saying that no, it's not the case. Like, we investigate the user like chat history, find that they have posted something previously in a different chat, and the way Inflection works is actually different from the like other chatbots, so that it can access like all your user history. And in the like Inflection terms of use, they actually claim that like we will not like access your personal data. We trust we value the privacy a lot, and we will only like access your data under certain circumstances. I guess this will also be some terms like the Microsoft will say that they're not going to like train on your data. OpenAI does that as well, but they also have some terms that saying that says that like they are going to access your data by some, I think, person, like confident, like bounded by some confidentiality terms at some circumstances. But I guess like there are people who do not want that happen at all, and I guess this is the reason why some of the companies want to really have their in-house models, and also some of the companies want to do not want your company to build a product that's solely based on some other companies' models. And I guess this is somehow like the reason why now there are more and more companies are investing to build their own model, either closed source, open source, but they want them in-house. Yeah. Yeah. So like there are actually like more questions. Like, I'm not sure if like any of ideas to any of the questions, like what applications do you want apply the vision language models for? What are the capabilities you want those open source multimodal models to have? What are the sources of supporting open source model serving on campus? Whether we can promote like try to see how the university are going to support us, and also what are the risks of multimodal models. And the last question is actually one of the questions that I'm thinking recently. Like, if our focus is not necessarily safety, but to improve the capability, do we want to RLHF it before we release it, just for the sake of like safety or alignment? Although we know that it can change our model's behavior, does not necessarily reflect like do we need to do that, even if our focus is not the safety? Yeah. Any thoughts on any of the questions?
Sorry, what is RLHF?
RLHF is reinforcement learning with human feedback, which is commonly used to like make your like answers fall align with humans' intent to be safe, polite, ethical, etc.
Nice.
Yeah.
So I guess I have a question. Like, what are the sources supporting model serving on campus? Because
yeah, that's my question.
Okay.
Yeah, because I think like when we're starting to develop those like open source models, if we find like serving those models to be useful, like I also want to like find such sources that are supported from our university. And I heard that like, for example, University of California, Berkeley have some support. They have some like university computing lab to support these kind of model serving and training. And we do have some clusters for training in our lab, like in our university. I think.
Yeah.
Yeah.
In CHDC.
Yeah, exactly. But I'm not sure about the inference, basically.
You deploy this.
We deploy it in our own lab machines.
On your
Funded by our advisor.
Basically server.
Yeah.
No, it's not deployed like AWS or.
No.
I think you could deploy them, but I mean there's a cost.
Yeah, exactly.
And then if you have a funding, like you might be discounted, like really be available to other people.
Yeah.
I have a question.
Sure.
It's not related to the ones up there, but have you explored data sharing on Hugging Face? Familiar with that process?
Yeah, so we have another collaboration with a different university on like building a benchmark for like sharing some of our like evaluation data, and you can convert your data into your like Hugging Face data set format, which is a Parquet file. And also like we've seen like Leon, they're like collecting users contributing like cross-sourced like data from Discord, and they convert them and release it on Hugging Face. But we do not necessarily see like people are like crowdsourcing on Hugging Face.
Yeah.
Yeah.
There's a lot of different data.
Yeah.
Do you know what the standard is for documenting those data sets? Do they use data cards, or do they include it in the model card itself?
I think they use data cards.
Data cards?
Yeah. Yeah, please.
Yeah, I have another unrelated question, but it seems based on the discussion that the whole community has converged on Hugging Face for sharing models, right?
Yeah.
Like that's where everyone landed. That's where you are. That's what we're talking about internally as we get ready to make models.
Yeah.
What are the pros and cons of Hugging Face? Maybe the pros are everyone's there already, so that's where they know to look for models.
Yeah.
I guess there's documentation. You're building more documentation for how you do it. You know, like in the Stone Ages of 3 years ago or something, we were rolling our own solutions and saving model weights just as files and making Zenodo repositories, writing scripts to download files, load them. And like, you know, all this stuff worked, but it was very much DIY. And we controlled it all. That was kind of nice. And it was all archived on Zenodo. I understand how that worked, and I know what Zenodo is as an organization. From an outsider who hasn't used Hugging Face to do these things yet, I don't know Hugging Face. Like, what's their governance structure? Who's going to own them in 5 years? What are they going to look like? And do I have to buy into the transformers and make all my models and work with the transformers library? And some of this is on my mind because with code and software, same thing happened with GitHub. There's like GitLab, there's these other small players. I think Bitbucket died, kind of, right?
It's still around.
It's like, they got squeezed out. So everybody's on GitHub.
Yeah.
The power player, we're all on GitHub. And then a month ago, one of my GitHub organizations got banned. And like, they just got banned, and we couldn't figure out why. And every single repo just got wiped out. And GitHub support wouldn't respond to our tickets. And every repo was gone, and everything that depended on those repos just broke. And they didn't respond to any of our tickets. And it made me think, like, who are these big tech companies that we're just throwing all of our support behind?
Yeah.
And it took finally one of the organization's members who knows a friend who's employed at GitHub to like work around the support channels and get an answer for what happened.
I see.
So, this is what I'm asking my questions from is who are Hugging Face and what's their deal and what's their future and who owns them, and should we trust them with all of our data and models?
Yeah, I think
it's heavy, but what do you think?
Yeah, that's a good point. Yeah, and I guess like for us, like currently, like we want a place that we can share our model and that can host our model and that can be easy to use. And it seems like this is the only place that we are gonna like make our model land. But I guess that's definitely a valid concern, and like there are already like plenty of grounds that like what it can become in the future. And maybe like in one day you're going to like I guess like for this I do not have a good answer, or like I can just have some nice hopes.
They are a nonprofit organization, if that helps a little bit. Fewer incentives to do bad things for now. They might change that later.
Yeah, I mean, like Pure J, the publisher, just got bought by Taylor and Francis. I always wonder.
Yeah. maybe the lesson is keep a copy of all your models.
Yeah.
But yeah, always.
Yeah.
So I have a question, like, what are the actual alternatives to Hugging Face? Because like I'm going through this process right now where we're getting ready to release a bunch of models, and like I've set it up as a GitHub repository package where you just import, package name and package.get model, and now you have a PyTorch object with the model. You can do whatever you want.
Yeah.
So like I've never really used Hugging Face. Like, is that really that different than Hugging Face? And then there's also like Torch Hub, which allows you to do something similar, like import Torch, torch.load the model identifier, and now you have the PyTorch objects. So like maybe like,
Is that worse than Hugging Face?
right, like is that worse? Or is like about the same as Hugging Face?
I'm not sure about like Torch, like whether you are allowed to upload your models to Torch Hub, but I guess, I guess like if so, then like maybe it's also a like good like alternative. But the only thing will be the support from like those transformers package, like the common workflow that are used to build those models. Like when you're like buying to one of the solution, like it's really hard to like switch to the other these days.
I think it's similar to the question of what programming language should I learn. It's whatever your collaborators are using. It really streamlines everything. It makes it easier to collaborate and people are on the same page.
Yeah.
You don't have to Google how to do this in this obscure language every time I want to do something. So the popularity is probably the biggest factor.
Yeah.
We have Copilot. You don't have to Google anything anymore. Yeah. Who co-piloted? I don't know. I will say the thing that I find a little frustrating with Hugging Face is that they're not entirely standardized in terms of how you report the model. So you make these model cards and document all the things that you think are important, but people sometimes don't have any information in their model card, or they have way too much, or just not relevant.
Yeah.
So, there's a lot of degree of customization that makes it kind of hard to navigate the model hub current, and I hope they change that in the future.
So this is more of a technical question, but like having not really used Hugging Face, like let's say I want to load a model from Hugging Face that was developed 5 years ago, and was using custom code that worked with PyTorch 1.12. Like, so does Hugging Face enable like you to use that environment, or now like is that an added difficulty of like, okay, I want to use Hugging Face, but it's an older model. Did something break in future PyTorch versions? Like, how do you know how that would work?
I think like that actually is somehow related to what we're discussing, that we would preferably have some Docker images from Hugging Face, but I don't think like Hugging Face is actually making you like more difficult in using those old models, because like what are the alternatives? Like the alternatives will also require you to have certain like Python package version, PyTorch version, the package dependency version. Like basically like that somehow like you have to deal with it.
Do you have time for one more question? I don't want to.
Yeah, of course.
So what do you do to keep track of your library versions, your Python version, PyTorch version, whatever? Do you upload those as tags within the Hugging Face model repository, or
yeah, so basically what we did is to like for all of our major updates to our code base, we will like tag them and also like add some release notes in like how we like release them. And for each of the model, we will have a like suggested version that can guarantee to work. and we for each of the version we have like pyproject.2ml, and which like includes the specific versions of Python packages. And yeah, we did not have the like Docker images yet, but I do think it's something good to have.
Yeah, I mean the Docker images are great if your goal is to reproduce like a paper result.
Yeah.
A lot of people don't need that level of reproducibility.
Yeah.
They just want the model weights.
Yeah.
That's good enough. But
yeah,
it'd be nice to have it down.
Yeah, exactly. Yeah.
You can build it from what you have. You can build a Docker image. Like
exactly.
Too.
Yeah.
You want a Docker image.
Yeah.
Right.
A question about LLaVA and capabilities.
Mm-hmm.
So I did great with the example of a guy ironing on a minivan. How does it do for like scientific figures and plots? Can it do any reasoning over those?
Yeah, because the current version is not necessarily fine-tuned for that, or like it's we did not like train it so much on to those plot reasoning, it may not necessarily do super well. But we do find on like we have another collaboration that finds that with as few as like 1,000 examples, LLaVA can adapt so well to that task already. Yeah. Basically, like I think the takeaway of like how like those open models performance on some certain tasks, I think is that the large language models these days are so good at adapting, and usually like only a few hundred, several thousand examples are sufficient to like fine tune the model to a certain behavior that even outperform some closed source models like GPT-4, as long as you have high quality instructions.